All right, today we're working with the analog side of signals on Siemens PLC. I have installed an analog signal module. This is an SM1234 AI AQ, which gives us 4 analog input and 2 analog output. For today, we're just concerned about the analog input side. If you're curious on how to add this module, check out the adding a signal module video. Whether it's analog, whether it's digital, process is still the same. The objective of today is to wire in an analog sensor. In this case, we're going to read a distance sensor. So I have an ultrasonic distance sensor here on the table. We first want to wire it up correctly. So I will pop up on the screen the Siemens manufacturer wire diagram as well as our sensor wiring diagram. What you need to do is combine both of those to figure out how this needs to be wired. In this case, my sensor needs power. So that is my brown wire and my blue wire. Brown being positive, blue being negative. My sensor also sends a signal back. That is the black wire, and that is going to the analog input here. Take a minute, make sure your wiring is correct, and then we will move over to the programming side. Looking down here at the table, we can see I have our analog distance sensor wired up here. I also made myself a little millimeter ruler here. That way, as we move this box forward and back on this, in front of this sensor, we can know exactly where it is. This will be very, very crucial in the setup for this. So whether you get one of these printouts from me or you grab a regular ruler, either way, you will need some known information to set this up. So that's what our setup looks like here. We will jump over to the computer side and start manipulating with this so we can read on our HMI how many millimeters this box is away from that sensor. Jumping over here to the software side of things, have a couple things preset up, have my PLC added. I have a couple PLC tags in here for buttons and for inputs, for digital inputs and outputs. I have an HMI loaded in here with a blank screen loaded up. I've gone and compiled and downloaded both of these. So my PLC has a blank project in it. My HMI has a blank project in it. We're ready to start programming. So we're not concerned about HMI right now. That'll be in a couple minutes. We're concerned up here in our PLC. So I have also, if we come to devices and networks, and we click on our PLC, I have added this analog input-output module that we talked about. Remember, if you need help doing that, come and see me or watch that adding a signal module video. But why I'm here is if I zoom in far enough here, you can see that that module has pre-assigned tags. So I can see that 0, analog input 0, is addressed as IW96. So now I know that if I want to read the value in this sensor, because I have it wired up to 0, I can find that value at IW96. So write that number down, jot it down, because now we'll come over here into our PLC tags and we'll make that tag. So here under new tag, I will click on new tag, and I'm going to call this raw sensor value, because this is going to be the raw value coming in from the sensor in the form of those counts. It is not a bool. This is going to be an integer, so I'm going to change this to integer. These are in alphabetical order, so integer. And we can see here now it's angry because it's not a digital output anymore. So this is where we set that address that we just found. So it was IW96. Enter. So now that should be where this analog sensor over here, that value is being stored. Easiest way to check that is we can now do a compile and we can do a download. Once we download that change of just that one tag to the PLC, we should be able to go online and start seeing counts in our PLC. So download successful. Go up here, click these little click the glasses up here, monitor all, and we should see the live values of all of these. There we go. So we can see some of our digitals are true, some are false. And down here in the IW96 category, we have a number. If you remember back to the numbers we talked about, the 27,800 number, there we go. So if we put this box over here and we start moving it forward and back on that sensor, you can see our count changing, right? So we are reading an analog signal in the form of counts. So that sensor is wired up correctly and it is configured correctly in our PLC. Now we just need to make these counts. So we need to make 5,525 mean something in real life. So we need to make it match what millimeters are down here. So our tag is in. So we'll jump over to the logic side and get that straightened out. So now that we have these counts here in our tag table, we need to now make that a value that is understandable to us as far as millimeters. So let's go offline. Actually, before we go offline, I want to note something to help us here in a second. So grab yourself a piece of paper. If you look over at the spec sheet for this sensor, you can see that this sensor is from 40 to 300 millimeters. So meaning it can read anywhere from 40 to 300. So 0 to 40 is essentially a dead zone, and then above 300 is a dead zone. So if I come back to here, before we switch over, put your box at 40. So we can see here 40 gives us 1,000 1,000 counts. Technically, it can go down to 0. So let's move it in a little. So 30 is a little 30 is a little in the negative. What's 35? 35 is 500. 30. 31 is 100. So we can just use 40 because that's what the manufacturer spec is. But we want to write down 40 millimeters equals 1,000 counts because that is going to be our low side. Now take it to 300. So 300 millimeters. Now we're at our max of 27,800. Let's move this in a little bit until we can see that value change. See, I'm moving that in up there. So there it just changed. So that was around the 290 millimeters. So let's use that. Let's use 290 millimeters equals 27,680. So now that I have this wrote down here, that will make our next step a little easier. So let's go ahead and go offline. Let's come to our program blocks in our main program. This is where we are going to use our NormX and our ScaleX technique. So on the top line here, over here on our side in conversion instructions, at the bottom we have a NormX and we have a ScaleX. So let's start with our NormX. This NormX is where we bring that raw value in. So right here, our value tag is going to be our raw sensor value. And our minimum is going to be 1,000. And our maximum is going to be 27,680 because that was our millimeter. That was our millimeter reading here. Now we have to make a normalized tag. This tag is going to do nothing other than pass this value from here to the scale X. So I'm going to do normalized value. I'm going to define this tag. It will be a global memory and it will be a real. So you can see here our norm X is taking an integer and turning it into a real number. Second part, I'm going to bring a scale X in. The scale X is going to take this normalized value and it is going to scale it between whatever two numbers we tell it. Well, this is why we wrote this down, right? So we are going to go 40 as a minimum and 290 as a maximum. 40, 290. Now out of here, we are going to get a distance in millimeters. So I will do distance millimeters. Define that tag. That will be a real in global memory. So there we go. There's our setup. That is how we bring from count to a readable value. Let's go ahead and compile and download this and see what it's working with. And let's go online. So now once we hit our monitoring tag, we should see these values starting to calculate here. If I put it to 40 millimeters, we should see our 1,000 counts over here, and we should see our 40 millimeters over here. If I go to 290, we should see our 26,680 there, and we should see close to our 290 right here. Now, so we set the whole scale. Now this whole thing is active and measuring. Let's set it to 100 millimeters. So we're at 98, almost 99. So that's fairly close. Do 150. Yep, we're all right around it. So now we know exactly where this box is at all times between those two scales. And we've taken our count number and made it a value that now we can understand. So our next part here is let's get it on our HMI. So I want to do a few things. I want to first, before I leave my program side, I want to add one more instruction. So you noticed our value over here was a couple decimal places long. I don't necessarily need that on our HMI. So I'm going to come into our convert instructions and I'm going to drag a round instruction right here. And I'm going to grab that distance in millimeters. And I'm going to move it into a tag called rounded millimeters. Now I'm just concerned about the whole numbers, right? That will just make it a little cleaner on our HMI side. I need this to be real and define. So obviously I'll have to compile and download because I made that program change, but that will help me here in a bit. So let's come down to our HMI. I'm going to minimize my PLC, maximize my HMI. Let's come to screens, root screen, And here we have a blank screen. So all I want to do, at least for this example, is just see that value on my HMI so I can see this moving without looking in the PLC. So over here under elements, I'm going to grab a IO field. And I am going to open that here on the HMI. I'm going to make it nice and big. So I have a couple setup things I have to do. I have to click on properties. And I'll make this a little bigger here. I have to click on properties, and I have a lot of settings in through here. So starting with general. General, what tag am I looking at? So I will click specify tag. And we will come up to the PLC default tag table. And here I want to grab that rounded millimeters. I could also grab distance millimeters. I'll grab rounded millimeters. So now this text box is tied to that tag. What type of tag is it? Is it an input? Is it an output? Is it both? It is an output from the PLC, and it can't be changed. It's just whatever the PLC is putting out. Over here, decimal format is fine, but I don't need all of these positions. So I'll do 3. And I don't necessarily need any decimal places. Okay. So now here I can change appearance, I can change the color, I can change the size. That's all fine. I want to fit the object to its content size, meaning that it's just as big as the text. And then here in this next one, I'm going to change the font size. So I'm going to change this font size to, let's say, 72. Okay. And that's about the setup. I'm going to add one more thing. I'm going to add a text field and just call it millimeters. And I'm going to increase that text size just as a label. That's completely unnecessary. But at least this way now we know that is how many millimeters it is. All right, so we will compile and download to our HMI. I will reconfigure the camera here, and we will see our finished product. All right, here's our final product. We have our program loaded up onto our HMI. We have our program in our PLC. We have everything configured here. Now, we can set this box to anything on this list, on this ruler here. We can set it to 140. There's 140. We can set it down to 45. There's 45. We can go the whole way up to 290. We can go anywhere between. So there you go. That is the calculation of a distance sensor in Siemens TIA portal and how to view it on an HMI screen.